So we've got an example here of a problem or a situation where you might have to apply this to. And so the very first thing that I always do, the number one thing, is I go through and I try to figure out my numbers. Figure out the numbers. Okay? So when I'm looking at this, I'm going to take my blue and I'm going to identify the cold. So I look for my lowest temperature water, and my lowest temperature water is 5 degrees Celsius. My hottest temperature water is going to be my 50 degrees Celsius. And so I'm going to go through and appropriately label this as my hot and this as my cold. Now, the other two numbers that I have here is how much. And if you remember back to our Frayer model, we need to know how much we have. And so they are equal numbers, and this is going to tell us how much cold we have. And this 10 degrees is going to tell us how much hot we have. And so we need to go back through and we need to apply equation number 1 to find the final temperature. And we know that our final temperature is hot temperature plus the cold temperature divided by 2. And so our hot water was 50 and our cold was 5. And we are going to divide that by 2. So we are going to take 55 and divide it by 2, which is going to give us a final temperature of 27.5 degrees Celsius. And so that is step number 1. Step number 2 is about finding change in temperature. Remember, triangle T, triangle meaning change. And so we need to take the final temperature minus the starting temperature for both the hot and the cold waters. So let's get some more working space for this. Let's start with the change in temperature for the cold. And so our final was 27.5 degrees, and our starting temp for the cold was 5 degrees. And so we are going to get a change in temperature of 22.5 degrees Celsius. Our change in temp for the hot, we are going to plug in that 27.5 degrees Celsius, and we are going to subtract 50 from it. And this time we are going to get a negative 22.5 degrees Celsius. So we now have our change in temperature, and we also have our final temp, which means that we can actually go in and we can calculate out how many calories of energy was transferred in this transaction. And we're going to do this with equation number 3. So this is brand new information. Equation number 3 is where you solve for calories. And we are going to do that by taking the change in temperature, which you figured out in step number 2, and you are going to multiply that by the mass of what you have. Now again, you have to do this twice. You have to do this once for the hot and once for the cold. So let's take a look and figure out the calories for the cold. So cold calories is going to be our change in temp for the cold, which was right up here. So I'm going to put 22.5 into my equation, and I'm going to multiply that by the mass, or how much I had. And that is up here in my equation. How much I had was 10 milliliters. So I'm going to take 22.5 and I'm going to multiply that by 10, which is just going to have me move that decimal place one place over to the right. And so I'm going to have 225 calories that was given to the cold water. And again, we have to do that for the hot calories. And with the hot calories, I'm going to take my change in temperature, which was negative 22.5, and I'm going to multiply that by 10. Again, I'm going to move that decimal place 1 over, and I want you to pay attention to how I'm writing the answer here. 22.5 calories. Now, some of you might be saying, hey, wait a minute, what about this? What about that negative number there? Okay, well, this is important, and I'm going to start a new page to look at it. Because calories can't be negative, because if it was negative, then that would mean that energy was destroyed. And the law of conservation of energy states that energy cannot be created or destroyed. Energy, as we have been talking about and thinking about when we think about heat energy transfers, is only transferred from one state to another. And as we've learned, it typically goes from hot to cold or high to low energy. And so because of this, your answer for calories can never be a negative number. So unfortunately, we just kind of have to throw out some of our math knowledge with that, and we have to follow the law of conservation of energy when we go forward with this. So we are going to be applying this information in class in different ways as we are thinking about energy transfer this week. And I want us to keep in mind those three words: